When we're asked to factor quadratics, we can't always just assume that we've got to take out the GCF, or to use the trig, or to factor difference of squares, or to use Steve's method or some other method. We have to work with what we have. So we're always going to go through multiple steps to make sure we get all the factoring done as possible. The very first step always when factoring quadratics or higher level polynomials is to take out the GCF. So when we look at this trinomial, we don't even say, oh, quadratic trinomial, here's a value that's not 1, let's use Steve's method. That would be skipping ahead. We have to start at the beginning, which is to factor out the GCF. Our GCF is 5, so we'll factor it out. It doesn't go away, it just comes out front of our set of parentheses, recall. So this is 5 times x squared. This is 5 times negative 7x. And this is 5 times 10. So when we factor out our GCF of 5, we've kind of dealt with this portion. We can leave it here. It's important that it exists, but we can forget about it. Now we look inside the parentheses. What do we have here? We have a quadratic trinomial. We have a equal to 1. And so this can be factored in the next step. The next step is to say, what do we have in the parentheses and how do we factor it? We have a quadratic trinomial where a is 1. We can factor that using the trig. What multiplies up to 10 and adds up to negative 7? Negative 5, negative 2. Again, the trig tells us that this set of parentheses factors out to 2 sets of parentheses. X, and then it's minus 2 and minus 5. This is the final form in factor notation of this polynomial. We went through the steps. We factored out the GCF. It left us with a trinomial. We factored our trinomial. We finish here because this is not a quadratic. We can't factor it anymore, and this is not a quadratic. We can't factor it anymore. We're done. Here's another example. We're going to start with step 1, which is to factor out the GCF. What number goes into 27 and 12? 3. So it comes out front of your set of parentheses, and we're left with what we're left with. 3 goes into 27 9 times. So we get 9x squared. When we take the 3 out of the negative 12, we get negative 4. That's your first step, taking out the GCF. Step 2, recognizing what you have here inside the parentheses. 9x squared minus 4 is not a quadratic trinomial. There's only 2 terms. But it is difference of squares. 9x squared is a perfect square. 4 is a perfect square. And it's subtraction. So we can factor this out using the difference of squares method. Which gives us 2 sets of parentheses from this one, where the first number is the square root of the first term, 3x and 3x. And the second number is the square root of the second term, 2 and 2. And then we get plus, and we get minus. After we factor this difference of squares, we're all done. This is the final form in factored notation of our original polynomial. We could check our work by foiling these 2 out and then distributing the 3 back in. We would arrive